So if you look at the slabs here at Nilpena, a lot of them just look like a big jumble of shapes. And it can be really hard to tell what those shapes are, and if any of those shapes are actually organisms. So in order to figure that out, we have to look very closely at these shapes and start to learn more about them. So one of the things we can do is we can put them into categories. When we look at these slabs, the shapes are not random. They don't occur in all different sizes and all different orientations. There are shapes that are round, there are shapes that are oval, there are shapes that are tubular, there are shapes that are tiny little circles. And so what happens is when many of those shapes get combined together onto one surface, it can look like a chaotic jumble. But if we very carefully examine each slab and pull apart all of those shapes, we discover that it's not as chaotic as it first appears. Well, there are some predominant forms that we find in these Nilpena Ediacaran rocks. One of them is a fossil that we call Dickinsonia, which is an oval shape that can come in a variety of sizes from about this big to about this big. Dickinsonia has ripples on its surface, little lineations as we call them. Another specimen that we often see on these rocks is called aspidella. Aspidella is a disc with smaller discs inside it, concentric rings. Shapes like this are very hard, in fact impossible to explain as being phenomena that were created by anything but life. What kind of life created them, we're still not sure about. One of the challenging things here is to actually decide if all of these patterns that we see in these rocks were once alive. And so there's a number of different ways that paleontologists look at shapes and patterns in rocks to determine if they're actually fossils or if they're structures that were created by other processes. One of the criteria that we use are abundance. We don't just see one aspidella fossil, we see many of them. We see them in different sizes, but those sizes are within a range. And we see them on multiple beds, not just in one spot. Similarly, we see fossils like Dickinsonia in different sizes, in different shapes. Sometimes they're folded, sometimes we can see that the fossil has been damaged while it was being preserved. And pieces of evidence like this help us decide whether or not a shape in a rock was once living or not. Other things that can make patterns and shapes in rocks that aren't biology are pieces of stone and debris that are pushed along by, say, a large storm that can scrape into the sediment below and leave divots. Other things that can occur are mud cracks, where in very shallow water, a muddy surface will be exposed, the mud will dry, and very distinctive cracks will form in the surface. Then later, more sediment will cover that mud flat area and fill into the cracks, and those shapes can get preserved in the rock record and can be very intriguing looking and have often been mistaken for fossils.